compound inequalities of first degree in one variable. When more than one conditions exist in a given inequality, it is called compound inequality. For example, here we have three inequalities. It is important to understand which of these will be read as how. In example 1, we read x is greater than 3 or x is equal to 3. The word or joins both of the possibilities or both of the conditions in this inequality. The second example, x less than 3 or x equal to 3, is again both conditions are joined by the word or. In example 3, the inequality can be read as -3 is less than x and x is less than +3. So these three kinds of inequalities are compound inequalities, and it is very, very important to understand that if two conditions are joined by the word or, then the solution set of the inequality is union of the two separate solutions of those conditions. And if two conditions of the inequality are joined by the word and, then the solution set is intersection of the two separate solutions of the two possibilities. Here we have a couple of questions, and let's get started to work it out. The given inequality here. So question number 1 here is given inequality is -3 is less than x, -3 is less than x, and x is less than +4. So here there are two separate conditions. The first condition, -3 is less than x, that is independent of the second condition, which says x is less than 4. But the word and joins them. So the final solution of these compound inequalities will be equal to intersection of the two separate solutions of these conditions. Let's split this into two conditions. So here we have -3 is less than x, and this is joined by the word and, x is less than +4. So if we have a number line here, then -3 is less than x. What does it mean? It means that every number to the right of -3 is solution of the first part of the inequality. So every number to the right of -3 excluding -3 itself, because here it says -3 is less than x. So let's draw an empty circle because -3 itself is not to be included. Then every number greater than -3 is in the solution of this condition. So we draw a line to the right indicating that this part is the solution of the inequality 1, or the condition 1 of this inequality. And the second condition, or the second part of inequality, is x is less than +4, means that every number to the left of +4 is in the solution of this inequality. So let's identify +4 here, and let's draw an empty circle because 4 itself is not part of the solution. So when we draw an empty circle and then draw a line to the left, indicating that this part is in the solution of this part of the inequality. And here we have, and now we can see that this solution, which we can write it as x, where x belongs to R, means set of real numbers, and -3 is less than x, is the solution of this part. And the final solution, because that has to be intersection of both of these solutions, so I put the intersection sign there, and then x, where x belongs to R and x is less than 4, is solution of the second part. And if we combine both of these and take the intersection, mean the area which is common to both, then that area is this area which is common to both of these solutions. This will be the solution of the given inequality, and we can write here equal to x, where x belongs to set of real numbers, and -3 is less than x, and x is less than +4. That is solution of the given inequality. Now the question number 2 here is again, that is, find solution of the compound inequality. So given inequality is, given inequality is 10 minus 4x, 10 minus 4x is greater than or equal to x plus 15 for x belonging to R. This is important that you understand the statement x belongs to R. R is set of real numbers. If the question would be x belongs to n, this will totally change the solution set. So it's very important that you pay the close attention to which set x belongs to. Now this condition is again a compound, means that it's a combination of two conditions. So let's split this compound inequality into two simpler ones. So we will say that 10 minus 4x is greater than x plus 15, or x 10 minus 4x is equal to x plus 15. Remember, this is read as or. So we will solve each one of them independently, and then finally we will take the union of these because we are using the word or. Here this would be 10 minus 4x. We want to collect terms involving variables on one side and constants on the other side. Therefore, we are going to subtract x from right side, minus x, and we have to do the same thing here, or similarly 10 minus 4x equal to x plus 15, and then take away x here and take away x here. The purpose is to transfer x from right side of the equation. So this will give us new equation and a new inequality. This would be 10 minus 5x greater than minus 15, and it is plus 15 here. In fact, this is plus 15 and this is plus 15, or 10 minus 5x equal to 15. And now we want to transfer this 10 from this side to move on to the right side, because we want to isolate x on one side. So therefore 10 minus 5x greater than plus 15, and take away 10 here, or 10 minus 5x equal to 15, and take away 10 here, take away 10 here. This should give us minus 5x greater than 5, or minus 5x equal to 5. So in order to isolate x, we will be dividing both sides by the coefficient of x. So this should give us minus 5x divided by minus 5. And remember that in case of inequality, if we divide a negative number or we multiply a negative number, it changes the direction of inequality. So this greater than will become less than now, 5 divided by minus 5, or this minus 5x over minus 5 is equal to 5 divided by minus 5. Now if we continue with this, x has been isolated, x is less than 5, or 5 divided by minus 5, or x equal to minus 1 here, and we can write this one as well, x less than minus 1, or x equal to minus 1. On the number line, the first part shows if this is the number line. If this is the number line, then and minus 1 is, if 0 is here, minus 1 is here somewhere. In the first solution of this first part of the inequality, every number to the left of minus 1 is part of the solution of this. So this is x, where x belongs to R, and where x is less than minus 1. If this is the solution, it only tells us that x are the numbers to the left of minus 1, not the minus 1 itself. Union, the solution of the second, is obviously minus 1 itself. So if we take the solution, now the union tells us that minus 1 itself as a solution of the second part, and union all the numbers to the left of minus 1 are make the overall solution. Therefore we have this solution set equal to x, where x belongs to R and x is less than or equal to minus 1, both of these. So this was x less than, this was empty because this doesn't make part, and minus 1 itself. So these are the solution of these compound inequalities.